All right, in calculus lesson 2.5, implicit differentiation today. We need to distinguish between a function in implicit form or explicit, and then we're also going to find those derivatives of the implicit ones. So state if it is explicit, implicit, and then find its derivative. Y equals 3x squared minus 5. Is this simple to solve for y? Yes, it actually already is solved for y. So we would say that y is explicitly written as a function of x. This would be an explicit function. Its derivative would be very simple. It would just be y prime equals 6x, and it's finished. This one, if I try to solve it for y, could you easily solve it for y? No, you could not. So this is when we talk about the implicit. We do not have the skills to write this variable y explicitly as a function of x. So this would be an implicit differentiation since we can't solve that for y. Now, implicit differentiation, when we go to take these derivatives, this is going to be the derivative of x squared is still 2x, just like we're used to. And we're going to put 2x, the dx in with respect to x. This derivative, negative 6y squared, and then that's the derivative of the letter y with respect to x. The derivative of 4y would be 4, and again we took the derivative of y with respect to x, equals the derivative of 2 is a constant, which would be 0. Now dx over dx would just be equivalent to 1. So this is just equal to 1. And I need to solve for my dy dx at this point, so I'm going to subtract the 2x over, factor out my dy dx, and then divide. And there's our answer. Now, if it was multiple choice, they would probably change this to a positive, and a negative there. They'd multiply everything by the top by negative and the bottom as well. But this answer is also correct if it's open response. All right, so on this one, would it be easy to write the function in terms of y equals in terms of x only? See, it would. It would be y equals 1 over x. So this one would be explicit also, because it is the variable y can be written explicitly as a function of x. Y equals 1 over x, or y equals x to the negative 1. Then to take its derivative would be negative 1 x to the negative 2. Again, don't leave the negative exponent. So explicit is when you can solve for y explicitly in terms of a function of x. If you can't, then it's implicit. So differentiate with respect to the given variable. So these were all with respect to x. This derivative would be 3x squared dx. See, I took the derivative of this variable x with respect to x. So that answer is just 3x squared. All right, I want the derivative with respect to x, but my equation is y to the third. So my answer would be 3y squared, but I took the derivative of the letter y with respect to x. That has to stay my answer this time. So the derivative of x is 1. Again, it's derivative of x with respect to x. This derivative is 3, but it was the derivative of y with respect to x. So my answer is 1 plus 3 dy dx. To take this derivative this time, we would have to do the product rule. We have x multiplied with y squared separately. The derivative of x is going to be 1, and that's dx dx. Derivative of y squared would be 2y, but dy dx. You cross multiply and you add, and there would be your derivatives. Now, where we're going with this is things are going to be with respect to time. Typically, we'll talk about with respect to time in almost most of our formulas and application. So that's where this is leading us to eventually, where they'll be with respect to t instead of with respect to x. So differentiate with respect to the variable again. So with respect to x, this would be 6x, and then it's dx dx. Derivative, 12x squared. So with respect to x, we're good. This one, derivative, 20y to the fourth, but it's dy dx, because that variable is y, and it's with respect to x. This derivative, negative 6x dx dx, would just be 1, so therefore this would be my answer. Notice this time my derivative is with respect to a. So that derivative is 8y, derivative of y with respect to a, dy dA. This derivative, negative 10x to the fourth, dx dA, derivative with respect to a, but the variable was x. The derivative here, 12a to the third, dA dA. That's the only one that goes away. Everything else stays the same. So find this derivative given this function. Can I solve for y easily on this problem? I hope you're thinking, no, I cannot. You got y cubed, y squared, minus 5y. I mean, there's just no way solving for y, not with the skills that we have at this point in our lives. So what we're going to have to do to find the derivative, we're going to have to do it implicitly. So that means I'm going to have to take the derivative here with respect to x. So 3y squared dy dx. 2y dy dx. Minus 5 dy dx. Minus 2x dx dx. So that one's just minus 2x. The derivative of that will be 0. Now I need to find what dy dx equals. They want me to get dy dx by itself. So I would add 2x to the right side, factor out my dy dx here. Now I divide by all this junk. That gives me my dy dx by itself. And there's your derivative. So it says you can see how you can use an implicit derivative. Consider this graph. So from the graph, we can see that y is not a function of x. Here's that equation that we just did. Even so, the derivative found in example 2 gives a formula for the slope of the tangent line at a point of the graph. The slopes at several points are shown. So if I'm looking at the point 2, 0 on the graph, which is here, the slope is negative 4/5 when I plug it into that derivative. The point 1, negative 3 right there, it's over here, the slope would be 1/8. The slope at x equals 0. Here's x equals 0. Right there, that slope is 0. If I plug 0 in here for this x, 2 times 0 is 0 over whatever the y's are. The slope at the point 1, 1 right here would be undefined. That would be that vertical tangent line, and that slope would be undefined. And you are not expected to know how to make this graph. All right, finding the slope of a graph. So find the slope of the tangent line to this graph. So we're going to take its derivative, and then we need to plug in this x and this y into the equation to get our slope. So the derivative is going to be 2x for the x squared. This derivative is 8y, but dy dx. The derivative of 4 would be 0. It's a constant. So therefore, I could subtract the 2x and divide by 8y. That's what dy dx equals. Now I could, since it wants the slope, just plug square root of 2 in for x, plug that value for the y, and find what my dy dx equals. So I'm multiplying by this reciprocal over here. So the numerator, negative and negative is positive. 2 times a pair of 2, so that'd be 4 over 8, which is 1/2. If I finish solving that for dy dx, that'd be negative 2x divided by 8y, which is the opposite of x over 4y. Still, plug in x, plug in y, and still get the same answer in the end, whichever way you choose to do that. All right, find the slope of this graph at the point 3, 1. So here's a picture of the graph. This is a limescat. I want the slope here at the point 3, 1. That should be a positive answer. If I get a negative answer, I know I did it wrong. Okay, because look at this tangent line. It has a positive slope. Now I need to get the derivative. So the derivative of the left side is the chain rule. That's the smiley face stuff. 3 times the smiley face squared. So it'd be 2 times 3 is 6. Smiley face to the first power times the derivative of what's in there. Now, the derivative of this side, a lot of students don't see that as the product rule. So you have 2 different variables that are not agreeing. So I would have to take the derivative of the 100x separate from the derivative of the y and then cross multiply and add. So that's why I wrote 100x and 100 and y and dy dx here separately. And then I would cross multiply add for that derivative on the right side. So again, the derivative on the left side was the chain rule, the happy face thing. So 2 times 3, there's the 6. The happy face to the first. Derivative of the happy face, derivative of x squared is 2x. Derivative of y squared is 2y, dy dx, because that variable didn't agree. All right, these two was cross multiply and add. So 100x dy dx, 100y. Now y'all, they're asking you for the slope here. What, x is 3 and y is 1. I would not try to solve this for the equation dy dx. I would plug in 3 for my x's and 1 for my y's right now. That would be really complicated in getting our dy dx by itself. So once I plug those in, right here, this is 10 times 6, that's 60, times 6 and times 2. Over here, I've got 300 dy dx plus 100. And go ahead and get these two together on one side, get the 100 and the 360 on the other side, and now divide by 180, and we've got what dy dx equals. All right, so again, we're at the 10-minute mark. So I'm going to pause the video and we will start the next one in just a second.